All right. When we create classes in our code, we're classifying, literally classifying the kind of stuff that goes on in our problem domain. When I say problem domain, I mean the problem that we're trying to solve, the problem that we're writing our computer application for. So in the examples I've been going over in class, our problem domain is a pizza shop that only sells pizza, sells very limited kinds of pizza, but it sells pizza. And we've said that there are pizzas and there's orders. All right, that's it. All there is. In the assignments, we've been doing sort of an academic setting where you have students and courses. But really, if we think about it, it's more complicated than that. Most real life problems are more involved in that. Not only do you have classes, but you sort of have subcategories of those classes. For example, you may be a student, all right, but you might be a graduate student versus an undergrad student. All right, that would be one example. You might be a non-citizen student. You might be a student that came in from another country to study here at LC. You might be a part-time student. You might be a student taking non-credit classes. So there's different kinds of students, and yet they share a lot of things in common. Now, let's think about our pizza example. We're going to focus on the order aspect of our pizza example. Now, so far we've just had a single class for orders, but really there's different kinds of orders. And let's think about those for a minute, the different kinds of orders that we have. Different kinds of orders that our organization may have. So we've said we have orders. There are dine-in orders. There's pickup orders. There are delivery orders. Right? And we might even find more categories if we thought hard enough. There might be DoorDash orders or Grubhub or Uber Eats. Now, when is it important to recognize these different kinds of orders? And I will call these subclasses. They're subclasses of orders. Orders is the main class. We have orders. That's one way of classifying the data in our problem domain. But we have sort of related underneath that subclasses, like dine-in orders, pickup orders, delivery orders. Let's just consider those three and we'll forget about Grubhub and all those. We may come back to those in a little bit, but let's forget about them for now. Now, some things all orders have in common. So for example, all orders have a customer that's placing the order, right? If you go in and you say you have a table for 3, the name is Mike. Well, Mike's the customer. Or a pickup order. Mike, I order these 3 pizzas and Mike is going to come pick it up later. Or whatever. Or a delivery order. Deliver this to Mike at 1005 Abbey Road North. All right. All these things, all these different kinds of orders have a customer. So I'm going to put that under customer because all orders have that customer. All orders have a list of items. And in our case, in our very simple example of a pizza shop, all orders have a list of pizzas. So if I dine in, I might order 2 pizzas. If I have a carryout order, I may order 3 pizzas. If I have a delivery order, I may have 4 pizzas delivered. All right, so there's a list of pizzas associated with every kind of order. It doesn't matter. It's a pizza shop, we sell pizzas. Every order that's placed is going to be for a certain number of pizzas. There is the cost of the order. Do all orders need the cost of the order to be calculated? Sure. If I dine in, or if I pick up, or if I get delivery, I still have to pay for the order. So all the orders have a cost associated with them. Now, here's an interesting thing though. If we think about it, all orders have a cost, but there are different ways to calculate it for different kinds of orders. So dine-in orders have their own method of calculating the cost of orders because they include sales tax. Pickup orders, there's no sales tax associated with it. So there's a different way to calculate the order, the cost of the order for a pickup order. And delivery orders have included in the cost of order a delivery fee. Not to mention maybe a tip for the driver. And there might be a tip for a dine-in order too. So they all have a cost, but the cost is calculated a little bit differently in all the cases. Now, let's think of some more things. The table the person is going to be seated at. The table number. Most restaurants have some kind of code table number to tell you what table they're sitting at. Well, a delivery order doesn't have a table associated with it. Neither does a pickup order, but a dine-in order does. When the pizzas are going to be ready, well, dine-in order, you might say, yeah, they'll be ready in about 10 minutes. Pickup order, you can pick these up in 10 minutes. Delivery order, well, the pizzas will be done in 10 minutes, but it's going to take a certain amount of time to deliver the pizza. So all orders have the bake time. But they also have, for delivery orders, have the delivery time. So no matter what kind of order you have, it's going to cost, or it's going to take a certain amount of time to bake the pizzas for the order, regardless if it's a delivery, if it's a pickup, or if it is a dine-in. All right. Now, the difference being that with the delivery order, there's something else. There's a delivery time. Delivery order needs an address. If I go and dine in a restaurant, they're not going to ask me my address. They don't care, right? They might not even ask me my phone number, right? When you dine in, you probably don't give them your phone number. But for delivery orders, and probably carry-out orders or pickup orders, you need phone number. All right. So how are we going to accomplish this? How do we code it so that we can efficiently code it so that we're not duplicating a lot of code. One of the primary rules of programming is, I'll make this real big letters, DRY. Do not repeat yourself. So I said here at the beginning that all these pizzas have, all these orders rather, have some information about them. How do I create my classes so that I'm not duplicating, coming up with the cost of the order, right? Remember that logic that we wrote where we looped through the number of pizzas on the list and summed up the total cost of the pizza? We certainly wouldn't want to write that code 4 times or 3 times, because that code is the same. To come up with the base cost of the food on the order is going to all be the same. We're going to loop through the list of pizzas that are on the order, and we are going to add up their cost to calculate the bake time. Doesn't matter if my order is carry out or if my order is delivery, it's going to take a certain amount of time to bake the pizzas on my order. All right. We wouldn't want to write that code where it's in a couple different places. Why not? Well, when you repeat yourself, that leads to some problems. Repeated code means that there's a chance of inconsistencies. I may calculate something one way in one case, another way in another case, and have it be inconsistent. Whereas all orders have the same bake time. It takes the same amount of time to bake an order for a delivery order as it does, or a pizza for a delivery order as it does a pizza for a carry-out order. If I have repeated code, though, I could have 2 different versions of that code and they might be inconsistent. Or even with the price information, I could have price, if I have repeated code, I could price the information differently in the case of a carry-out order as opposed to a dine-in. And we wouldn't want that either. The other thing is it makes it harder to maintain. By maintain, I mean coming back and changing the code later on. All right. Why are we interested in that? We're interested in that because we almost always have to do that in any project. You might have heard someone say something like the only constant in the world is change. All right. And that's true in software development. You can count on whatever it is going on now is going to be different sometime in the future. You might not know what, you might not know what's going to change or how it's going to change, but you're pretty confident that there's going to be changes. All right. So we want to eliminate the duplicated code so we don't have to make the changes in 2 different places. If the way we price a pizza changes or the way that we calculate the bake time changes or anything like that. So how do we get around this conundrum? The fact that we have different kinds of orders that we want to have, but we don't want to duplicate code. We do it by creating things called parent classes and subclasses. The parent class is always the more general case. More general or less specific. In fact, well, I'll mention that in a second. So a more general word is order. A more specific word is pickup order. A more general word is student. A more specific word is, or phrase, is graduate student. So we're going to create a class that's going to contain the general stuff, and then we're going to create a class for the more specific information. So in the order example that we were talking about, the more general term is order. So we're going to create a class for order, and that's going to be the parent class. Now, the subclasses are the more specialized or more specific. And we're going to use what's called inheritance for that. Another word for inheritance is specialization, where we define a more special case of that. And our subclasses in this case are going to be the pickup order, the dine-in order, and the, what was the last one? Delivery order. All right, so how is this going to work? We're going to put in the main class everything that all orders share. So we said before, what are some of the things that orders share? Well, they share a customer, they share a list of pizzas, they share the cost of the order, although it may be calculated differently, and they share the bake time for the order. So the things that are common to all these different subclasses are going to be put in the parent class. That is, they're going to be put in the order class. In these, we're going to put everything specific to a pickup order. Here we're going to put in everything specific to a dine-in order. And finally, for delivery order, we're going to put in everything specific to a delivery order. Then we're going to specify that these subclasses inherit from the superclass. Parent class and superclass are the same thing. The specific language we use in Java is that they extend the superclass. Parent class, again, also known as superclass. So we're not going to design a complete order system for all the different kinds of orders, but we are going to look at how we might implement the delivery order in our old pizza example. All right. So let's go back and look at a newer version of the pizza example, one that includes a subclass. So I'm going to go and open up these different files. My unit test, pizza, my order, and a delivery order. Now, unit test we'll come back to in a few minutes here. Pizza, we don't make any changes to. That's one thing that's powerful about this object-oriented programming. All the things that we defined about a pizza and we've defined in the pizza class stay the same regardless of the kind of order, right? Pizza still has a size, pizza still has a crust, Pizza still has or doesn't have pepperoni. Our constructors are the same. We have our get and set methods. We calculate the bake time based on this. This doesn't matter what kind of order it's on. We calculate it this way. So we don't need to do anything to pizzas. If we added a different kind of pizza, like maybe a stuffed crust pizza or a sheet pizza, let's say, where the rules were different for that kind of pizza, then we might create some subclasses for pizza. Well, in this example, we're not touching the pizza class. So what are we touching? We're touching the order class and delivery order class. The order class, in fact, which sort of represents the basic dine-in or pickup. I guess this would represent the pickup kind of order. But this is just the basic structure of an order. An order has a name and it has a phone number. All right? And it has a list of pizzas. We have our constructors. In this case, we have one constructor. We have our get and set methods. We have to calculate bake time. We have to calculate price. All that's going to remain the same. Now, our delivery order is a subclass. And in this, we're going to code the things that are different than for a regular order. So, what's the difference in a delivery order? Delivery order, you need the address. You need the city, state, and zip. In addition, the way we calculate the cost of the order is going to be different because we need to include the delivery fee. So we start out by saying pizza class, or pizza class, public class, delivery order extends order. That means that order is the superclass or the parent class. Delivery order is the child class or the subclass. That means we get everything in the order class and we don't have to redefine it. So the delivery order, even though you don't see it in the list here, we still have the name and phone number. Notice I have the word protected here. That used to be private in our earlier examples. What protected means is simply that both the class and anything that inherits from that class can access that property. But we don't have to put on the delivery order the fact that an order has a name, or the order has a phone number, or the order has a list of pizzas. Why not? Well, because we've said that this extends the order class, which means it gets all those attributes automatically for free. We're going to save the constructor for a little bit later today. We'll probably get to it today. If not, we'll talk about it next week. But it has its own constructor. Notice it doesn't need a set and get for name. It doesn't need an add pizza method. It doesn't need to calculate bake time or calculate price. Well, maybe it needs to calculate price. But it does need the things that are different. So it needs a set and get for the address, set and get for the city, set and get for the state. Now, we said that an order, a delivery order, has a delivery time. So we calculate delivery time by calculating the bake time and adding 30 minutes to it. We're assuming that we can do, we're like Domino's. We can deliver in 30 minutes to anything that we deliver to. I have the word this here. This means this particular object. So this particular delivery order object. Now you might say there's no calculate bake time defined in the delivery order object. That's true. It's defined in the superclass. So if I say the name this, and if I say dot calculate bake time, what that's going to do is it's going to call this class's calculate bake time. And in our particular instance, calculate bake time is defined on the order level, not the delivery order level. So it's automatically going to call this function here. Then we simply add 30 minutes to it, and that's the delivery time. Calculate price. Well, we said calculate price is, if we go back to our diagram here, calculate price for a delivery order is the regular cost per order plus a delivery fee. Well, that's what we have calculate price. Double price equals super calculate price. Super calculate price means call the calculate price method that exists on the superclass. So we'll call this calculate price. That will loop through all the pizzas and it will calculate the price. And to calculate the price for a delivery order, then we have the extra $5 delivery fee. Now let's see how this works in action. Because I have an order here that we create using our constructor. We add pizza 1 and 2 to that order, calculate the price, calculate the bake time. Here I create a new order. Let me change this to delivery order. I create a new delivery order. I call the constructor. What does that do? That sets the address properties. And oh, by the way, it calls the constructor on the main class, the superclass. When you call the constructor on a subclass, it also has to call the constructor on the superclass. And we'll see a number of different ways you can do that, either next week or the week after. But this is one way. This says call the constructor that accepts the name and the phone and do these other things. So we've created our delivery order. We add 2 pizzas to it, and then we can ask what the cost of the order is, what the bake time is, and what the delivery time is. So let's compile this and run this and see what we get. Okay. Java C, star.java. I forgot to save file. We'll talk more about why I got that error. I don't know if it was today or not. Pretend that didn't happen. And we get no errors. First piece is a small, thick crust, pepperoni false. Bake time is 16, price is 9. Large, thin crust without pepperoni, bake time is 10 minutes, price time is 12 minutes. So these two pieces and these two pieces are identical. But I have two different orders here. I have the pickup order, which has the cost of the order $21. That's the sum of those two, 9 and 12. And the bake time is 16 minutes. That's the bake time of the longest pizza. And the cost of the order for the delivery order is $21, the sum of those two pizzas, plus an additional $5 delivery fee. The bake time is still 16 minutes. And then finally, the delivery time is 46 minutes, which is 30 minutes plus the 16-minute bake time. So I can add a pizza to this order, even though there's no add pizza method in the subclass. Why? Well, because that exists in the superclass, and that is a code that will get executed. It always looks to see if there is a version of the code in the subclass. If so, it runs that. If not, it will run the code in the superclass. So there's no add pizza method in the subclass. Therefore, it calls the add pizza method in the superclass, the order class. Now you can go more than 2 levels down. For example, add up here, even though we didn't do much with them, that there's other kinds of delivery orders, DoorDash, Grubhub, Uber Eats. These could all inherit from delivery orders because those are all kinds of delivery orders. Right? So a DoorDash order is a delivery order. A delivery order is an order. So I could make DoorDash order inherit from delivery order, and delivery order inherit from order. So you don't just go one, you can go more than 1 level deep. There can be a chain of parents associated with a class. And this allows us to do a lot of categorization. If we did this for student athletes here at the college, we might have a student athlete class, we might have a soccer player class and a tennis player class, and then go on from there. In soccer, you might have a subclass for goalie, for example, and for the other positions. And then you could go down as many levels of inheritance as you needed to. How do you tell if something inherits from something else? You apply what's called the ISA test. In other words, if I do this, and it forms a true statement, then this, on this side, is a subclass of this. For example, a delivery order is an order. Is that a true statement? Yes, it is. Delivery order is just a certain kind of order. So that's a true statement. Therefore, the delivery order class can inherit from the order class. If I did the reverse, it's not really a true statement. An order is a delivery order? Well, not necessarily. Could be one of the other kinds of orders. So that's not true. Therefore, order cannot inherit from delivery order. Delivery order can inherit from order. A pickup order is an order. Yeah, that's true. So I could go in and define a pickup order class that was inherited from order and be just fine. A pickup order is a delivery order. No, that's not true. Those are two different things. And neither is a delivery order a pickup order. But I could say a DoorDash order is a delivery order. That's a true statement. And then we would make our DoorDash class to have everything that a delivery order has. So it would inherit from that, and it would have the things that are different. For example, it would probably have like the Dasher ID number or something like that. So if you're going to determine whether something inherits from something else, do the ISA test. Another way to say the ISA test is to say is a type of. So a delivery order is a type of order. A pizza is a type of order. Is that true? No. Pizza is not a type of order. Pizzas are contained on an order, a list of pizzas, but a pizza is not an order. So that's a different relationship between those objects, sometimes called composition, where a list of pizzas makes up part of the order. I want to try to hit the highlights here. We define the thing that every order has in common in the order class, the thing specific to delivery order in the delivery order. In our constructor, it's going to call the constructor on, it needs to call the constructor on the superclass first, and then it can do other things. And in this case, the constructor for order contains those two attributes. So by saying super that, I'm calling the constructor on the superclass, that is on the order class. And then I'm doing the other things. That constructor doesn't handle address because there's no address on a regular order. We don't need to define things that appear on the superclass unless they are different. So we don't define any of these sets and gets, because if we were going to write them, they'd be identical. Likewise, add pizza. Likewise, calculate bake time. What we do need to put in the class are the things that are in the subclass and not in the superclass, whether it be attributes or methods. So these are 4 attributes that are not in the superclass, but are in the subclass, so we have to add them. We have to add the sets and gets. because those are not in the superclass. Calculate delivery time is a method that doesn't exist in the superclass because not all orders have a delivery time, only delivery orders do. We also put in the subclass things that are different. So calculate price is a little different for delivery orders. We still calculate the price of all the pizzas, the basic calculate price that's on the order, but we then add on the delivery fee. So we put that function in the subclass because that's different than in the superclass. Now we can use super to call the method on the parent class, or this to call the method on this class. This is a little subtle thing. I could have used either this or super in this case because this doesn't have a calculate bake time function. Therefore, this object's calculate bake function appears in the superclass. Very, very, very important concept in object-oriented programming and Java. So we'll be going through more and more examples of it. Do go through the materials that are part of the module. Here's a quiz that's ungraded. Read the question and don't peek, and see if you can answer these. These are good things that, you know, sometimes places publish like common interview questions, and those are good to study. So what is inheritance? Creating a new class using an existing class requires all the properties and behaviors of the parent class. Why do we use inheritance? We can reuse the code. DRY, do not repeat ourselves. What is a relationship? Represents inheritance. What is the subclass and superclass? Go through and review these, and there might be some things that we didn't cover in class, but it gives you the answers right here. Some things we didn't get to, but we will get to many of them in future weeks. All right, that's all I had for today. We will see you next week.